All right, so now let's do that same problem by picking the vertical element instead of the horizontal element. I usually tend to pick vertical elements just because I find dx easier to work with. But here we'll pick the element. And again, its area is length times width. So its width now is along x, so it's dx. But what is its length? Well, it's from here to here. That distance, that's the coordinate xy, that distance y. So it's going to be that distance all the way up minus that distance. So it's 1 minus y times dx. We want our integration to be with x, therefore we need to replace all the y's with x cubed. All right, and then the center of that element, they're all at the same x, so the x of the element's x. The y of the element, yl, is going to be the middle there, which we can get by averaging the two endpoints. So that one's y1, that one's y over 2. So the y element will be 1 plus x cubed over 2. So to get the area, then we're going to integrate dA, 1 minus x cubed dx. That'll be integrate 1, you get x, x to the 4th over 4 from 0 to 1. Didn't put in a 1 there. Let me get that fixed. Got a 1, so I'll plug in 1 to this, plug in 0. That's 1 minus the 4th, that's 3/4. So that's the same thing we had earlier. So same answer as it should be. The area doesn't change because of the way you calculate it, not if you're correct. All right, and then we have to do those other two integrals to get the element. To get the x circuit center mass or center of centroid, we're going to have to do, they called it QY, so it's XL dA. So we have to take our XL, which is just x, take our dA, which was that, multiply through, so you're integrating the x minus x to the 4th. Your limits are the same, 0 to 1, so we get x squared over 2, x to the 5th over 5. From 0 to 1 will give you 1/2 minus a 5th. 5 minus 2 is 3/10. Same thing we had earlier. Or there's where I actually plugged it in, upper element minus lower element. And that gives us 0.3. To do, and then the x coordinate of the centroid is that over our a, which gives us 0.4. To do the y, same thing, y element dA. Our y element is 1 plus x cubed over 2. Our dA is 1 minus x cubed dx. That's a sum and a difference, so it ends up being, x plus y, x minus y is x squared minus y squared. So it'll be 1 minus x cubed is x to the 6th. Then we got the 1/2. So you integrate that, you get an x, you get x 7th over 7th. From 0 to 1, plug in your 1, you get 1 minus a 7th. That's 6/7 times a half, 3/7. Or if you let MathCAD do it, you get 0.429, which is the same as 3/7. You do your qx over a to get the y coordinate of the centroid, and there we have exactly the same x and y coordinates of the centroid of that blue, depending on, the details are very different depending on whether you pick a vertical or a horizontal element. You'll just have to play with them, and I would do several problems both till you get a feel for which one's easier in which situation. All righty. If you got any questions, send me an email.